Okay, in today's lesson we're going to be covering Boyles Law. So on this assignment, these first few questions, those are all related to the notes that we did. And also you can answer probably most of them based off your note card here for Boyles Law. Alright, so just review comparing Boyles Law. It's a little bit different than Charles and Lusak's. It's an indirect relationship. Alright, so that means if one of those variables increases, the other will decrease, and vice versa. All right. So our units again is comparing pressure and volume. So pressure can be in atmospheres, kilopascals, or milliliters of mercury. Volume you will see as milliliters, liters, and sometimes you might see as a cubic centimeter. But this is what we're going to use, and here's the formula. Instead of cross multiplying, it's basically a straight up algebra equation. So note card out and a calculator. All right, we're going to focus on answering question number 4. So again, Boyles Law, what I'm going to write up at the top as a reference, I'm just going to put the formula again. It's P1 times V1 is equal to P2 times your V2. So, looking here at question 4, I'm going to read the problem and underline key information as I go. It says, a gas occupies 0.4 liters and exerts a pressure of 0.9 atmospheres. What must the volume become in order for the pressure to be 1.8 atmospheres? Okay, so I got my 3 variables. So I can distinguish which one I'm looking for. I like to list them out. So I'll put P1 equals, V1 equals, P2 equals, and V2 equals. All right, my first pressure is 0.9 atmospheres, so 0.9 atm. My first volume is 0.4 liters. My second pressure is 1.8 atmospheres. Which means I'm looking for the volume, and I notice in my question it says what must its volume become. So we are looking for this. So I circle my target. We're looking for V2. Also, when I look at my card, Boyles law is indirect. So if one variable increases, the other has to decrease. I'm looking at my pressures. Pressure went from 0.9 and increased to 1.8. So my pressure increased, which means I know my volume is going to decrease. So whatever my volume number is, it should be less than this number, 0.4. All right, so we're going to plug this into the formula. So P1, 0.9 atm times V1, 0.4 liters. That is equal to P2, which is 1.80 atm, and then V2, we don't know what that is. So I want to get V2 by itself. So to do that, I have to take 1.8 atmospheres and just divide it to both sides. So 1.80 atm on this side, and divide over here. 1.80 atms. Alright, I know this cancels out, so we're left with V2. And so now what we need to do is just solve this. So with your calculator, we're going to take, turn on, say 0.9 times 0.4 equals, and divide it by 1.80 equals, and we get 0.2. So 0.2. Now this is a volume, so our volume that we were given is liters, so it has to be the same unit in liters. And that makes sense to me because when we looked at our Boyles Law indirect relationship. If one variable increases, the other has to decrease. Well, pressure increased, so therefore volume must decrease, and 0.2 is a decrease from 0.4. Not much of one, but it's still a decrease. And so there's your example on how to solve for Boyles Law.